Okay, so let's draw an RL circuit. So this is resistor and this is inductor, and in this video we will find the equation of current and also the voltage of this inductor using MATLAB, and at the end of the video we can see that this is the equation of the current. Well, so let's start. So first of all we have to obtain the differential equation of this circuit. Well, so let's do this. So first of all let's write the equation of inductor. So we can write V is equal to L di by dt, where B is the voltage of the inductor. Now what is V? The inductor voltage will be equal to source voltage minus the voltage across this resistor, which is equal to IR. Well, now let's simplify this equation, and if I simplify this equation I will get di by dt. I will simply divide the whole equation by L and then I will rearrange this equation. So if you pause the video you can understand that the simplified form of this equation looks like this. Okay, so now what I will do, I will do a Laplace transform. So I will apply a Laplace transform here and let's see what happens. So we know the formula. So if I transform this I will get as the Laplace transform of the current, then I will minus initial current, right? But in the code I have written that initial current is equal to I initial. So let's write I initial here. Well, so now let's transform it. We have to write simply R by L, then we have to write the Laplace transform of current I, which is equal to capital I. Well, so now let's transform this Vs. So what is actually Vs? If I come here, so this is the source voltage Vs. Let me draw a Vs versus time graph. Well, so when time was negative, that means less than 0, Vs was 0. That means we didn't switch on Vs. But at the time t is equal to 0 we have switched on the source, and that's why this voltage becomes, let's say, BDC. That means this graph looks like a step function U. So we can write Vs is equal to BDC UT. Well, so Vs is equal to VDC UT, and if I now transform this I will get VDC. We know that Laplace transform of U is simply is equal to 1 by S. So let's put this Laplace transform BDC 1 by S here. So let's write it BDC 1 by S. Okay, so now I have to simplify this equation. So if I simplify this equation I will get, let's write this here, BDC divided by L S. Then I have to take this thing at the right hand side, so I initial, and then I have to divide S, then R by L. Well, so let's now go back to our code. So you see that first I have written here clear variables, so it's a good practice to write it, and then I have defined some symbols using this sims function. So these are some symbolic variables, these are not regular variables. You can see that I initial, it is a symbolic variable. Okay, S, T, I, all are symbolic variables. Okay, so now let's make this equation. You see I have made this equation, I have made this equation here, and then I have applied a inverse Laplace function. It's a built-in function of MATLAB. So I want to transform I, so let's write here I, and I is a function of S, so let's write S, and we want to convert this S domain into time domain, so let's write here T. And let's see if I run this portion, you see I obtained the equation. So this is the equation of the current across the inductor. Well, now let's try to find voltage across this inductor. So we have a formula, V is equal to L di by dt. Let's write it. So v is equal to L di by dt. So these are in time domain. Let's transform it into s domain. I mean, let's apply Laplace transform here. So I will get capital V L. Then if I transform this, I have a formula Si minus I this, right? And this is the initial current. Let's write here I initial. Okay, so now I have to make this equation. So let's make it. Well, so let's see. Okay, so let's write here capital V, which is equal to L then S into I minus I initial. Okay, so now let's apply inverse Laplace. We want to convert V, which is a function of S, but we want to convert it into time domain, and let's take the output in another symbolic function. Let's say that is small v. Well, now if I run this simulation, run this portion, so you can see, so this is the equation of the inductor voltage.